Hello everyone and welcome to St. Andrew's Institute of Technology and Management, Gurgaon, Delhi NCR. St. Andrew's Institute of Technology and Management is the best college in Delhi NCR and entire India. We provide 100% placements. Our students get the best result and university ranks. This is the best college that you can get admission into. We offer you a variety of courses from BTech, BBA, BCA, and we are soon starting with MBA, LLB, and architecture. This is a dream college. The subject that we shall be taking over here is Principles of Software Engineering. Code is CSE 302F. This is a CSE 6 semester subject. The syllabus is in accordance to MDU University Rohtak. The topic that we shall be taking over here are system design, design concepts and principles, the design process of design and software quality, and design principles. I, Shalini from CSE department, shall be taking you forward. Design principles. See, the software design should correspond to the analysis model, right? Which is very correct. So, whatever the model that we have analyzed, so our design should be in accordance to it, right? Because anything that we are planning has to adhere by to the plan that we actually made in our mind, the conceptual plan, the requirement analysis phase, and all the stuff that we have already completed. So, this has to be in correspondence to the analysis model. Often, a design element corresponds to many requirements. Therefore, we must know how the design model satisfies all the requirements represented by the analysis model. Next is choosing the right programming paradigm, which is very important. A programming paradigm, it describes the structure of the software system. Depending on the nature and type of application, different programming paradigms such as procedure oriented, object oriented, and prototyping paradigm can be used. This is what we have already seen when we did our SDLC models. We saw this how we were doing prototyping life cycle models and all that stuff. So our programming paradigm has to be in accordance to this. The paradigm should be chosen keeping constraint in mind such as time, availability of resource, and nature of users' requirements. Software design should be uniform and integrated. See, software design is considered uniform and integrated if the interfaces are properly defined among the design components. For example, like rules, formats, and sheets. So all these actually are provide uniformity, right? And they help to integrate. So all these have to be established before the design team it starts the designing of the software, right? And it has to be flexible. Why? Because anytime if any change occurs, so your model should be prepared to handle the change. You should be able to modify, you should be able to build around it, right? So it should be flexible enough to accommodate the changes of refinement, modularity, and abstraction. Next point is fifth point, software design should ensure minimal conceptual errors, right? So we should design keeping in mind that we are making minimum errors, right? So from first step only we should be careful towards the error part, because if you keep on making small mistakes from the starting, then after like few steps these mistakes will enlarge. So you should ensure that from the starting only you make minimum errors, whether it is semantic or it is syntax error, they all should be minimum. Then software design should be structured to degrade gently, right? So it means that if any unusual changes occurs, like, or any circumstances happens, and you have to terminate it. So it should be in a proper manner, right? So you do not affect any software. So the degradation also, just like you build it up like that, that one thing need to be independent in other thing, like modularity I can say call this thing. So what we can say that when it degrades also, it should degrade gracefully. Seventh point is software design should represent correspondence between the software and real world problem, which is very true. See, anything that you're designing, you should be able to relate it to the real world problem that you are solving, right? So your design has to be systematic and it has to be realistic. Software reuse, right? So whatever is the biggest advantage when object oriented programming came. So what was the biggest advantage of object oriented? This I already discussed in my initial slides. See, the object oriented, the biggest advantage was that it provided you with reusability of the code. Reusability, because you divide it into modules and then again these can be used again, right? So for you don't have to code from scratch. So this is what made it easier, and it really made it more effective and convenient for the writers also and for the users also, right? So this is a very very important concept. And then we have designing for testability. See, usually we say that the testing phase we keep it separate, but if we look at from the point of view of a real world problem or anything real that we really carry out, we should see the testing actually has to be done in each and every phase. You should always make a phase and then you can see that if it is correct or not, right? So this has to be, it has to be kept in mind that this testing phase and this has been is supposed to be quickly followed and quickly implemented after the design phase, right? That is, first the software is developed and then handed over to the testers, who subsequently determine whether the software is fit for distribution and used by customer. However, it has become apparent that the process of separating testing is seriously flawed. Why? Because as if any type of design or implementation error are found after implementation, then the entire part of the software requires to be redone, right? So that your means your effort is getting more used, right? So you involve the testers from the initial stages, right? This is what I was making you understand. See, and see, they should be involved with analytics to prepare tests for determining whether the user requirements are being met, right? So you should always keep this thing in mind. Next we come to prototyping. Okay. See, prototyping we discussed in our SDLC models. What we were doing, we were making a prototype that is a working model, and then we were we wanted to take a requirement kind of clarity from that, we took it, or if we want to throw it about and take another course, then also we were doing this. So in this prototyping also, it should be used when the requirements are not completely defined in the beginning, right? So this is used when they are not completely defined. So you actually do not have a clarity about the requirements, which is what we did into prototyping model also, right? So the basic purpose of the prototyping is that it helps you refine the requirements, or it provides you the kind of, it provides you a very I would say clarity of thought also, along with the requirement also, right? So it is a quick mock-up of the system, and this can be used as effective means, gives the user a feel of what the system will look like and demonstrate function that will included in the developed system. So this helps in reducing risk of designing software that is not in accordance with the customer's requirement, right? This is really important. I hope the design principles are clear. So next then I'll move to design concept. So now you have a clear understanding of the 10 design principles that we discussed, and you brave enough to write the answers, right? So now we come to design concepts. The first concept is abstraction. See, abstraction you've seen in OOPS lectures also, and like, what is abstraction if I ask you? Like, it is hiding the details, right? So abstraction is like wherein the meaning is hidden, right? And it is hidden from, as if it's at an abstract level, right? So abstraction refers, this allows the software designers to consider components at an abstract level while neglecting the implementation detail of the component, right? So you don't have to actually undergo into the implementation detail, but you can actually be at an have an abstract understanding of the model. So you do not have a kind of, I can say that you do not just like in kind I would say that you don't require the actual job of doing a mason and kind of stuff. You can have an abstract knowledge and that will do also, right? So the concept of abstraction can be used in two ways. First, as a process and as an entity. As a process, it refers to the mechanism of hiding irrelevant details and representing only the essential features of an item, right? So you hide all the irrelevant details and then you only show the essential features, right? So that one can focus on an important things at that time. And as an entity, it refers to a model or view of an item, right? So what is the view of that item or what is the model of that item? And process, you will hide everything that is irrelevant and you'll only see the essential features, right? Next we come to architecture. Okay, so software architectures refers to the structure of the system, which is composed of various components of a program or system, the attribute properties of those components and the relationship amongst them. So the software architecture enables the software engineers to analyze the software design efficiently, right? So you have to do a proper component analysis of them. Next we come to modularity. See, I was discussing this modularity in case of when I was discussing this usability with you, right? In the design principle. So this modularity concept actually provides you this reusability of the code, and you know why? Because it divides your programs, your software into various modules, and then these can be separately addressable, right? So you can actually address them separately and in different ways, right? So a complex system is partitioned into a set of discrete modules in such a way that each module can be developed independent of the other module, right? So after developing the modules, they are integrated together, and they are integrated together to meet the software requirements, right? So you note that the larger the number of modules a system is divided into, so greater will be the effort required to integrate the module, which is very obvious. See, if I divide my one piece into 10 parts, then I have to work less actually to kind of bring them together. But if I divide that one piece of log, say into 100 parts or 1000 parts, then the integration part has to be really very kind of effort taking. Why? Because there are so many parts and then I have to actually work on the integration level of each and everything. So this modularity, that it has to be coarse or fine, it depends upon this your system requirements and individual's choice, right? So this is very efficiently you have to plan it out. And next we come to information hiding. See, modules should be specified and designed in such a way that the data structures and processing details of one module are not accessible to the other modules, right? So you hiding them, right? Hiding what? Hiding one module from the other module. So the one module does not know what is actually deep inside the second module, right? So they pass only that much information to each other which is required to accomplish the software functions. So what is it doing? It is actually giving you software functions and the information that is local to that module, and it is hiding all the irrelevant stuff. So this is information hiding. So this modularity, actually this information hiding is kind of vaguely this provides information hiding is providing you abstraction also, right? So this is like you hide and you don't reveal anything, so you're hiding all the information into kind of. Then we come to refactoring. See, refactoring is an important design activity that reduces the complexity of module design, keeping its behavior or function unchanged, right? So you actually these are unchanging, right? And your refactoring is defined as a process of modifying a software system to improve the internal structure of design without changes in external behavior. So you improve that internal structure of the design and you don't change the external behavior, right? So that is why it is refactoring. You're kind of refining, or I would say you're kind of like just we do the way we do interiors of our home, we change it, keep on changing now. So that is refactoring is there. So during the refactoring process, the existing design is checked for any type of flaws like redundancy, poorly structured algorithms, and data structures. So you have to look at them, like all the flows that you have redundancies, you have poor algorithms and DS. So you improve the design by refactoring them. So you do it internally, right, without getting it visible on the external part. I hope these are clear to you. All the kind of modules and all the kinds of principles and all concepts are there. So now all these basically design principles and all these concepts actually are there to provide you software quality, right? So your design and software quality is the actual goal basically of all these concepts and all these principles, right? So this is, I would say, the because ultimately the user experience matters, because what he is experiencing is what is important to us, right? So in the context of software engineering, software quality measures how well software is designed, like how well you're designing it and how well the software conforms to that design, right? So how well that software is in accordance to that design. There is the quality of design and the quality of confirmation. So it is often described as the fitness of purpose of a piece of software, right? So you actually see how fit it is for the thing that it is meant to do, right? So we have this product quality model, and this is an ISO model, right? So the first it you deals with functional suitability, right? The function, it looks after functional completeness, functional correctness, functional appropriateness. I won't be explaining because these are self-explanatory, and I have been doing it like since when I started with PSC. So you need to be very aware of all this kind of stuff. Then we have performance efficiency. So performance is always based on time and resource, right? It can be storage also and time behavior also. So that is why it is measured like time behavior, resources use, capacity. Then it goes to compatibility. Compatibility is coexistence and interoperability, which is very correct. Like, and I could say it like interoperability, coexistence, and the platform kind of, if it is really inter-platform stuff, we can also do it in here, compatibility. So this is the one chart that has been prepared by the ISO, right? Then I have usability. Usability deals with appropriateness, recognizability, learnability, operability, user error protection, user interface aesthetics, and accessibility. Reliability deals with maturity, availability, fault tolerance, and recoverability. Security deals with this is confidentiality, right? And integrity, non-repudiation, accountability, and authenticity. And then we have maintainability. So maintainability deals with your modularity, reusability, analyzability, modifiability, testability. And your portability has three parts: adaptability, installability, and replaceability, right? So this is the standard chart that is being prepared by the ISO, and each and every term is self-explanatory, right? So looking at the name only, you can actually tell what it is doing. So after this, there are some few more product quality. I can say that software product quality need to have, it need to, the product has to be correctness. The product quality has to be in conformation to requirement or program specification related to reliability. So whatever that you are being confirming it to, so it has to abide by them, amiable with it. Then it has to follow scalability, completeness, absence of bugs, fault tolerant, deals with extensibility and maintainability, and then documentation. So there are additional some standard defines in quality in use model. So there are 5 characteristics of quality in use model: effectiveness, efficiency, satisfaction, safety, and usability, right? So your model, that is quality in use model, we have these 5 standards. Then we have some key aspect of quality for the customer, which is very important. So it has to be good design, the look and style has to be nice, so you deal with this. Then we have good functionality, that is it does the job well, like it is doing whatever that it is meant to do, it is doing it very proper way. Then it is reliable. Reliable means that is it is acceptable, have a level of breakdowns or failure. Like, so if something goes down, if one component goes down but 2 3 components goes down, then it still functions well. Then we have consistency. So it has to be consistent. consistent with the consistent with this, with the whatever that your system requirements are. Durable, that it lasts as long as it should. So if it is meant for 100 years, it has to last for 100 years. 101 would be okay, but 99 would not be okay, right? So this is what you have to see. And good after sales service, so after delivering, then you should provide good service. So this is good after sales service. And then value for money, it should offer you nice value in return for your money. So I hope this is clear to you and you don't have any doubt in it. This is a very self-explanatory subject, the principles of software engineering. So I hope it's you find it really comfortable. So there's this important question: what are various design principles? Then there are various design concepts, and explain in detail design and software quality. Right. So please prepare them, and all the best. Thank you.